So it's a combination of lesson 10.5 and then the sphere is in 10.8. So we'll actually be pulling a couple together. A lot of vocabulary again, but once we've talked about it with the pyramids, there's similar vocabulary on cones. Okay, on pyramids and cones, how do they differ from prisms that we were doing yesterday? How is a pyramid different than a prism? It has one base instead of two. Okay. And then do you remember what the faces are called that are not the bases? What was that vocabulary yesterday? The faces that are not the bases. I guess we weren't looking at a pyramid. Okay, these were the lateral faces. The lateral faces on prisms yesterday were maybe rectangular, square, or parallelogram shaped. But today is a regular polygon. All of these triangles coming up are identical, which makes it nice to do surface area. If we know the area of one of those triangles, we can just take it times how many there are to do the lateral area part. Okay, some more vocabulary. There's a slant height on pyramids, and there's an altitude, which from yesterday is a perpendicular height. Okay, going straight up the middle of this pyramid, that is the altitude. That one's perpendicular. Now where is slant height? Slant height is going to go on the face, slanted. It still would be perpendicular if I look at only the face. It's not perpendicular to the bottom of it. Okay? So there's a slant height, and then there's a perpendicular altitude height. We have to use one in the surface area formulas and then a different one in volume formulas. And as I mentioned, lateral faces are all those triangles. So here we're starting to think, okay, surface area. We've got all these triangles that we have to find the area of and add together, and then we'll have one base. If we think of every triangle separately, it would be the length of 1/2, the length of the side, times, is this the height or the slant height? That's the slant height, because that's the height of the actual triangle. Okay. So 1/2 the base edge times the slant height, turn it, 1/2 base edge times slant height, 1/2 base edge times slant height, 1/2 base edge times slant height. If we put all those bases together, what's that called? What's it called when you go all the way around this base? Perimeter. So instead of doing those triangles separately, we can combine it and do 1/2 the perimeter of the base times the slant height. That would do all those triangles at one time. That's going to be your lateral area. Then add on to that how many bases? Just one for the total surface area. So if you think about that, the formulas that we have for pyramids, for regular pyramids, not oblique pyramids, regular pyramids, the lateral area is 1/2 the perimeter of the base times the slant height. And then the surface area is going to be that plus just one base. So in the end, we get slant or surface area 1/2 perimeter of base times slant height plus base area. And again, on the wall, this is your poster. I just put the base area in front instead of at the end. All right, let's try a sample. All right, if you're drawing a square pyramid, that's what this one is. Let's fill in some numbers for your example. It says find the lateral area and the surface area of a regular square pyramid. The base edge is 14. So if you were drawing that picture, put 14 on every edge of the base. And the slant height, how do you picture the slant height? If I go back to that last screen, can't see it real well on that one. Too far. Slant height, that's the one I wanted, right here. Slant height comes to the side perpendicular rather than to the middle of the base. Okay, so that slant height is the measurement of 25. Okay, let's see if you can find the surface area. Let's do lateral area first, I guess. All those triangles, what's the combined formula? Look at your notes. So what formula do I need to be using? For the pyramid, it's gonna have triangles, so there's gonna be a 1/2 in it. Looking on the right poster now? This one.
1/2 PL
You know what the L means?
lateral.
Slant height. Okay? So 1/2 the perimeter of the base times the slant height. Perimeter of the base, how many edges to the base? 4. So 4, and each one is 14. What's 4 times 14? 56. Okay, and the slant height is 25. So what's 1/2 of 56 times 25? 700. And we are on square centimeters. Okay, that's all the triangles. Now to get the total surface area, we have to add on one base. So the total formula was that lateral area plus one base. So this was 700. How do we find the base area? It's a square.
14.
It's 14 times 14, right? 14 squared. 196, 700, so we get a total of 896 square centimeters. Questions to ask? Did you get it figured out, Lucas, or is something different? No questions? Okay, let's show the solution and get another example. Okay, next one is what type of a pyramid? The the lateral area figured out?
Oh yeah,
Oh yeah? What is that?
about 480.
About 480? Let's see. Lateral area, 480. Okay, now what do we need to add on to that for the surface area?
Area of the base.
Okay, how do we do the area of the base?
It is a regular hexagon. Therefore, the measure of an interior angle is 60 degrees.
Okay, a couple of you are rattling on here. Okay, it's a hexagon, regular hexagon, even if that one doesn't look right. Do I have any measurement on it?
You don't. Oh yeah, 10.
10 for the edge. And what do I need?
You need the measure of the interior angle.
Okay, the angles would help us get to the apothem eventually. Okay, now this wasn't called maybe the interior angle. What was this angle called?
Oh, the central.
Central angle. And how many degrees is it?
60.
60. Divided in half?
30.
30. 30, 60, 90 triangle. What measurement do we know?
The length of the bottom leg.
30 degrees.
Length of the short leg.
The short leg is 5. So the long leg, which is the apothem,
10.
is not 10.
5 to square root 3.
The 10 is the hypotenuse.
Nope.
You gotta get your 30, 60, 90 in.
Oh.
This length would be 10. So the area of this base, the base area, whichever way you want to write it, area of the base is 1/2 apothem times perimeter of 60. That would take care of all those triangles. What's that? Round it to 10.
Around it, when you get done, round it to 10.
Oh, tenths. We usually go hundredths. Okay, so 60 times 300, 150 square roots of 3 is the base area. 300 and a half of that. Okay, so this is what I need to add on. I'll just put a capital B. This is the base that I need to add on to our last answer. What was our last answer?
400.
480? Okay, so surface area is gonna be 480 plus 150 square roots of 3. And I don't think I gave directions to go to decimal, but you probably are doing that, I'm guessing. Let me finish clicking my solutions here and see if our final number matches up. Surface area, 739.8. Okay, what questions on that problem? Okay, those regular polygons are popping up a lot because the bases of these shapes are regular. Okay, find the lateral area and surface area of a regular triangular pyramid. Let's see if we agree lateral area. Lateral area, 90
Oh,
square
yeah.
feet.
Yeah.
Okay, then what did we add on to get the surface area? I think I did mine with 30, 60, 90, whoops, too fast. 30, 60, 90 triangle. Go back one more. 100 and something it was. 105.6. Did we agree at the end? I was gonna have you show me on your marker board, wasn't I? I didn't do that. All right. Did you get it right?
So did I.
Okay, questions on that one? I think I did the lateral area or the final surface area too fast. Problem coming up with the base area? No? Okay. Let's switch to a cone. Initially we're going straight up the middle. And then there is a slant height on a cone also. That's probably on the next screen. The right cone is going straight up. You can have an oblique cone. If it doesn't go straight up, but it goes off to one side or the other, I don't have a good model for that. But I know I've eaten one of those before.
Hershey's Kiss.
That is, well, I think that's more of a perfect one. Is a Hershey's Kiss kind of tipped off to the side or the
I
other?
mean, it depends which one you get.
Yeah, I suppose it does depend which one. I was thinking of a waffle cone, like for yogurt or ice cream.
Yes.
If you, I don't think the top of it is perfectly flat. I think it's slanted a little bit.
I don't know what kind of ice cream.
You have to go get one and think about the cone there. That would be an oblique cone if it were tipped off to the side. All right, here I was talking about the slant height and the altitude a little bit ago, so there is a slant height involved. All right, the surface area, that part that I was showing you that's kind of hard to figure out, you take pi times the radius times the slant height. And that's what gives you the area of this region that has to wrap around to make the slanted part on the cone. It could be a small part of the circle, it could be bigger, just depends upon how big the radius is. But the lateral area is going to be pi times radius times slant height. Then we said we have to add on one circle to get the total surface area. So we're going to do pi radius times slant height plus pi times radius squared to get the whole surface area. Okay, let's try those on an example. Okay, draw yourself a cone in your notes there. Find the lateral area and then surface area. It's a right cone, so it's not tipped off to the side. It's nice, straight, perpendicular. The radius on the bottom is 9 centimeters. The slant height is 15 centimeters. So if you haven't, give yourself a picture. Radius is 9 centimeters. The slant height is 15 centimeters. Oops. Find the lateral area and surface area. Just keep it in terms of pi. Pi times the radius is 9, the height's 15. What was 9 times 15?
135.
Okay, so this is 135 pi square centimeters. Surface area would be that plus the circle for the bottom. RL plus pi r squared. This was 135 pi with a radius of 9. That means we have to add on 81 pi to the circle bottom. So we get a total of 216 pi square centimeters. Question on that one? Thumbs up or down? Jacob, thumb up or down? Which one? Got it? Anthony? Yeah? Okay. Moving on then. Find the lateral area and surface area of this cone. It's the hypotenuse. The
True.
slant height is the hypotenuse of a right triangle.
Oh.
So 8 squared plus 15 squared equals the slant squared.
Oh, I forget. 17.
So I think they said 17 is what we should get for the slant height. Okay, so watch out for, are you given the slant height or not? Now you should be able to pick the right numbers to find the lateral area and then surface area. Just keeping it in terms of pi again. All right, were you correct? Lateral area, if you already multiplied, Zach, by pi, try 136 times pi, see if that matches with your number. Okay, and then surface area,
That's what I got.
200 pi, so 200 times pi. Okay, get it right? So the only thing you had to watch out for on that one was, I gave you the perpendicular altitude height, not the slant height.
We have like math races.
Math races, well,
Like we go on the board and you like put a problem on it, and then we all just like we select certain people.
some of our problems take a while to do,
You got
so
some good
sometimes
math
those
lessons
aren't the
in class.
best. Okay, and based on the time, I'm gonna speed through a few things. Okay, this one, you had some problems like this on today's homework. Describe the effect on the surface area, like what's it gonna multiply by? The base edge and the slant height of the regular hexagonal pyramid are both gonna be divided by 5. So what's gonna happen to the surface area?
It's gonna be 25 times smaller.
Okay, some of you are getting the idea. When you're doing areas, it's the square of whatever you do to all the sides. You have to just make sure it's doing all the sides. So yes, it would be divided by 25 because you're making a similar pyramid. Okay, and I had this calculated just in case we needed it, but it didn't sound like we did. Okay, if the base edge length and the slant height of the regular square pyramid are both multiplied by 2/3, what's going to happen to the surface area? What's it going to get multiplied by? 2 ninths?
4 nights.
4 ninths?
4 nights.
4 ninths. Square each one. Okay. And again, I calculated just in case we needed that. So you'll have some surface area changes, some composite figures. What's that a combined shape of?
2 cones.
2 cones. Are the 2 cones the same?
We just need the lateral areas both.
Are the 2 cones the same? So we could do.
We need the lateral area of both of the cones, but we don't need the surface area of the circle.
Oh, you don't want to do the whole surface area? Is that correct? Lateral area, we don't want the flat bottoms anyway, okay, correct. Are the 2 cylinder, or cones the same? Could we do lateral area of one of them and take it times 2?
Well, they might be the same.
Well, I know their bottoms are the same, radius of 6.
Oh, it's a Pythagorean.
This one has a perpendicular height of 8.
That has a
This
hypotenuse.
one has a lateral area, slant height of 12.
That's slant height's 10 on that one because of the Pythagorean.
Okay,
triple.
Pythagorean triple, this would be 10. So they are not the same. But you did tell me lateral areas. So pi radius times slant, and then another pi radius slant, but this is from the second cone, this is from the first one. So we need to do pi times 6 times 12, and then pi times 6 times 10 that you just found for me. So 72 pi plus 60 pi, 132 pi. Combination shapes, you'll have some of those on it. Some combinations are done with spheres, so we better get the sphere in here so that we can do those combinations. And you'll find sphere if you flip to 10.8. I'm gonna click through a few. Alright, find where the sphere is. As far as vocabulary on a sphere is a three-dimensional circle. So a sphere is the locus of points in space. Simple formula for a sphere. And it is over here, the second one up from me, 4 pi r squared. So let's do a surface area for your notes. You're on section 10.8, where surface area was. I think I have 10.8 in there twice, once for surface area, once for volume. Okay, so a surface area of a sphere. The radius 4 times the area of the great circle. .38 squared ends up being pretty big. Then you have to take it times 4,
Makes it even bigger.
even bigger. Then you have to multiply by pi, but we're going to keep it in terms of pi. So you got what number?
5,776 pi.
5,776 pi.
5,776.
Use
Sí,
36.
36.
Yeah, I mean,
Okay, so 2 ways to think about it. If you found the radius or didn't, it comes up 196 times pi.
Yeah, they're doing this military. I don't know.
We use a different formula. Oh, yeah. All right, question on that one.
yeah, I keep getting a different number.
Are you just doing the multiplying? And I didn't multiply with the pi. Just 4 times 7 times 7.
4 times 10. Oh.
Right, and on this one, just be careful, I gave you the diameter, so be sure and use the radius of 25. Okay, let's look at a combination shape. And what happens if you divide the radius by 3? If you divide the radius by 3, what's going to happen to the surface area? Okay, so it's going to be divided by 9. And again, I calculated just to show you. All right, let's do a combo shape. I guess right there's one.
Oh.
What's that a combination of? So we will add the lateral area, the 1 circle, and 2 circles for that curved part. All right, now another version of that, I won't worry about completely calculating it, but I'll show you what it is. The next one that I had just tipped it upside down. Instead of the hemisphere going up, I guess I have to take off the bottom here. Take off that part from the cylinder and make it go down inside it.
It's too big. That's cool.
So how would you find this surface area?